Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to go over the CNM Computer Programming Concentration Capstone Project spec. So this spec describes the project you're going to do for your capstone, and you're going to produce basically three things. One is a portfolio that we're going to describe in a bit, a USB drive with all the programs you've taken in all your classes, as well as some programs you're going to reference in your portfolio. And then there'll be a debugging exercise that we need to figure out a date for. So I will, if for a face-to-face review of this spec, I will do that on Friday, the 14th of February at 10 o'clock in the open lab during Hackerspace. And I can also do that by appointment. Most of the times I will be at Hackerspace when it is open, and you can meet me there and I can review the spec with you. So the CNM CIS computer programming degree is based on some competencies that we've identified from information that our faculty and our industry advisory board has given us inputs to, and they result in these program objectives. The capstone that you're going to complete will be used to help us assess whether or not we're meeting those objectives. And in essence, the goal of our programming curriculum is to ensure that you know how to code in C++, C# and .NET, and Java, as well as possibly Python. The languages emphasize object-oriented design, and you also learn how to design an application that uses a graphical user interface and also can access databases. And we also have you take a Linux course, and you may also round out your degree with a number of optional courses that we offer. So our excellent competencies include the following, and you're going to, for your capstone, you're going to write, do some writing on these topics. The first competency is to be able to write classes and use inheritance and polymorphism. Next is developing an application that uses a graphical user interface and uses good documentation practices. And then your web app, you also need to be able to connect to a database. We also emphasize being able to do research to solve problems and using Google or other search engines, and then also debugging. And we are looking for you to be able to demonstrate competence in debugging in at least 3 languages. So you're going to create a portfolio, a USB drive, and complete a debugging quiz. And these are the percentages that those 3 elements add up to. So 70% for your portfolio, 15% for your USB drive, and 15% for your debugging problems. So the USB drive is probably the easiest thing to do. What you're going to do is make a folder in the USB drive for each course you've taken. I'll label it with the identifier for the course, for example, CIS 1513 or CIS 2520. And so you're going to organize it by course, and you're going to put the final versions of all the programs you created for that course in those folders. In addition, we're going to ask you to make a capstone folder, and any programs you reference in your portfolio, please place them in the capstone folder. These will be duplicates of the ones you have in the other folders, because we're going to ask you to use programs from the courses that you've taken as your reference material for your portfolio. You won't have to write any new programs for this capstone. You're going to do this assignment using the programs you've already written. And then we ask that, you put just the final version. So, if you have multiple versions of say program 5 for some course, we don't need all the different versions. We just want the final working one. The next part is developing the portfolio. So the portfolio is a document you're going to produce. It's intended to summarize your programming knowledge and to be used during job interviews or to be shown to university advisors who need to evaluate your knowledge. And we're going to focus on these competencies: writing classes and using objects, class inheritance and polymorphism, building GUI programs, building programs that connect to a database, and being able to do research. I'm going to ask that your portfolio be in a notebook with section dividers for various topics. It doesn't need to be fancy, just make it professional. For each section, you'll need code examples highlighting the pertinent code. Maybe so in some instances, you may want to put the entire project code in there, and descriptions which describe what you're showing. So, if you use Microsoft Word, for example, here on this document, you can do things like copy and paste your code into the Word document, and then use callouts. So under shapes, they have the option to put callouts, and you can put descriptions of what you're referencing and put a pointer. That will often make it easier to describe things. So feel free to use all the capabilities you learned in IT 1010 and to make a good Word document. So it's acceptable to use 2 programs to show one competency or 1 program to illustrate 2 topics. So for example, there will be minimums identified in the spec for how many programs you need, but you can use more if you need to. And your portfolio is going to be organized, your tabs are going to be organized in this way. Don't get creative here, just use the tabs that are identified here. So we're going to want your resume and a copy of this document and a table of contents in the front of the binder. And then you're going to have a section for classes and objects, a section for inheritance and polymorphism, a section for graphical user interface, a section for database, and a section for Google. These are the percentages that those will be graded on. So for this document, just print it out and you can put it in the front of the folder. I'm going to be marking all your grades on this document. I won't mark up your portfolio because presumably you will show that to an employer possibly, and I don't want to have stray marks in there. And then have a 1 or 2 page resume in the front of your folder or your portfolio. You can use the same one that you're going to turn in for the overall capstone project. A table of contents that should have these tabs in it identified. And then you shouldn't have to write any new programs for this project. You have many projects to pull from. If you need to use a new program, or you want to use a new program, or you want to use a program that wasn't one that you did in the course, that's fine. You can include those, but we're not requiring you to. The courses you have taken should provide you everything you need. Each selection should have code examples with comments and highlighted code illustrating the pertinent competency information. It's very important that we can easily see what you're demonstrating. Don't just put printouts of your code and assume that we know what you mean. I'm going to be basically evaluating this from the perspective of an employer reading your document. They will assume that they don't know what you know, and and the objective here is for you to write well enough to convince them that you know the topic. So assume they know nothing, and that you're explaining to or assume that they don't know what you know and that you have to explain it to them. You can assume that the person is reasonably knowledgeable of programming, but you should describe everything in fairly good detail. The portfolio should be organized in the order shown in the following table, this is the same organization as above. And so this is the rubric for how we're going to grade each one of those sections. I'm going to focus on satisfactory and good as I go through this. The portfolio presentation, the document should be neatly presented with a title page. Each section is tabbed and clearly marked. Program code, screen captures, and additional information are easily located. So basically, it should look like a professional document. It doesn't have to be fancy. You don't have to buy the top-end folder or anything. But put some tab markers between them and make it easy to find the sections. And you're going to see that throughout this, the key is good explanation. If somehow things aren't clear or it's hard to find things, then that will tend to take points away. So the real first section you're going to build is this class construction and object section. And what we're going to be looking for is a student can show the syntax file structure for class construction in all 3 languages. Here's the key. You need to have a minimum of 3 examples because you need to show an example in all 3 languages. And you're going to so C++, Java, and C#. You're going to also, when you do each one of those, you're going to show the class definition and where the objects are created. So the class definition is typically that thing that starts with the word class and is usually its own file that defines the class. Where the object is created is often in a function somewhere else, for example, in main, where you actually instantiate the class. So, for example, in C#, it's the thing where you say my class object is equal to new my class. In Java and C++, it's a little different. Realize in C++, an object is given to you when you declare the object, whereas in C# and Java, you have to new up the object. So that's a good opportunity to speak about those differences there. And then we also want to see in your classes examples of where you use overloaded constructors and functions. So your class is where you have a constructor and there's multiple versions of it with different parameters. That's what we're looking for here. Show that and talk about overloading in that section. Now, what you're going to find is that these specs are pointing to specific assignments that you've done. So don't try to make something that doesn't fit be your example for this. In this case, you're going to find an assignment where we had you do a class with some overloaded constructors, and you're going to see that in all 3 languages and use those as your example. Where you lose points if, maybe the code is present but lacks clear explanation, or you don't put all 3 languages, or maybe there's no overloaded functions. I'm going to be looking for what you put in the portfolio document. I'm not going to go dig into your program on USB. So I'm wanting you to explain these concepts in the actual document, and then have clips of the code that demonstrate that in there. So if that's not in there, then that's where you start losing points. The next section is inheritance and polymorphism. And so the student has written a complete application based on numerous programmer-written classes or derived classes. And the program implements polymorphism using an array, vector, or list of references or pointers. So you can look through your programs, but in each one of those courses, at one point we had you define maybe a base class, and you inherited from that base class, and then you made an array or a vector or a list, and its type was based on that base class, and then you put child class objects into that array, vector, or list. Look for that program. Notice that you only need to have one example of this a complete application. So you can pick one in any of the languages that you have and put that example into your portfolio and then explain, talk about inheritance, talk about polymorphism, so how does the child class inherit from the parent class? So you're going to probably have, at least, two, if not three or four classes referenced in this, with some some of them inheriting from another one as the base class. So I should see about two to four classes with code in this section, and then explain how the inheritance happened, and then how the polymorphism part. For the polymorphism part, you're probably going to have somewhere in main or in some other function or class where the base class is instantiated and the child class objects are placed in it. So I need to see that as well. And you should be able to explain the class relationships, how the polymorphic features are implemented, and the software design implications. So, why do we do this? One of the principles you can reference is the dry principle. Don't repeat yourself. So, the reason why we inherit is so we don't have to write the same things in multiple classes. And then also, there's usually a reason why we're using polymorphism, and often it's because we want a different behavior to occur for different types of objects, but we want one list or array to hold all of those objects. So think about that and reference that. You can also reference solid principles. And there's a Wikipedia article at Wikipedia Wiki Solid that goes into several concepts here that it's a good starting point for you to look at reasons why your program might have implemented inheritance and polymorphism. There's a single responsibility principle. Basically, your classes and your functions should have one purpose and should be fairly small. There's the open close principle, which basically says that if you need to make a change to a class, rather than rewriting it, it's better to inherit from it and add to it. So the idea is that classes should be closed for modification, but open for extension. List cost substitution principle is actually a good one to read that explains a little bit more about polymorphism. And the interface segregation principle and dependency inversion principle, these kind of work together. And basically the idea is you want to make your classes dependent. For the dependency inversion principle, make your classes dependent not on a concrete class, but an abstract or class or interface in the case of C#. And the idea here is if you make functions take an object that's abstract, you can extend that abstract class to build the concrete instances that will work with that function. So it'll be much more flexible. You can use that one program written one time on many different types of objects as long as they implement the abstract class. And then the information segregation principle is that when you make those abstract classes or interfaces, make them as small as possible. You don't want a giant interface which has every possible parameter in it. You want small ones. So this article can help you articulate why you're doing why you're using polymorphism and inheritance. Note that you lose points basically by omitting things that are required in the good section here, and or you can't explain it. Once again, make sure you explain it so that it's clear that you understand what these concepts are, so you can convince a hiring manager, yes, you understand what these things are. The next section is on graphical user interface construction. And we're expecting to see screenshots of your GUI in here. Console-based application is not a graphical user interface, so we had to put that in here. So you write a complete application using a GUI, and And the key here is that we want to see both API provided dialog boxes and custom dialog boxes. So API provided dialog boxes are like alerts. One that that we often make you use, that is a good idea to use here, is a file dialog. The one where it gets the name of the file that you want to save or open from the user. And that was also a good opportunity to show file IO. So look for the program which made you open up a file and get the file name from the user, and then you can reference it here. Alternatively, if you have a different API provided dialog box you reference here, at least find some piece of code somewhere that you can explain how you accessed a file from your program. We want to see both file and database. And then that's the API provided dialog box. The custom dialog box was the one where you had one form that you designed and built open another form that you designed and built. And part of that was, how do you return information from the child form back to the parent form? And typically what you do is you instantiate an object in the main form and you pass it through the constructor to the child form. Alternatively, in addition to, you might put a public property on the child form that is used by the parent form to get the data out of it. So I want to see an explanation of how the data is passed from a child form that you design to a parent form that you design. And then in addition, you should don't pick the super simple dialog or super simple GUI form application that you made. We're looking for the more complex one that has, parent and child form, and that should typically have a number of different controls on it. You should talk about those controls and how they're created and instantiated, and how they're configured. And also, typically there will be one of those programs that has a class that you write to hold the data. In fact, that's a thing that's going to be passed from the parent form to the child form. Show that class, talk about its purpose and how it's designed as a model that will carry the data back and forth between the two forms, and show how it's being passed back and forth. The source code should be well documented. It should be written using good C# conventions, and the program should obviously run well without any obvious problems. Where you start losing points is if you omit some of the things we're looking for here, or you can't explain it very well. The next section is database manipulation. And so you've written at least one program, typically in each course, which has you connect to data. So, basically it's going to have the ability, it's going to be the one that allows the user to create, retrieve, update, and delete data from a database. So look for that program and reference it here. Explain how the database was created. Sometimes you write code that actually instantiates a database. If you're using Entity Framework, note that Entity Framework actually creates a database for you if it doesn't exist, based on the information in the connection string. In other cases, you might have created a database actually in Visual Studio or in some database management studio, and you may have created it that way. However you create the database, capture a screenshot of either the tool which you use to create the database or the code that's used to create the database, and talk about that here. You should also show where the SQL statements or link statements, if you're using link and C#, actually are used to CRUD the database. So I want you to be able to explain how you you create, retrieve, update, delete the database at that point. And again, if you omit pieces or you can't describe, lacks clear explanation, then you would lose points on this. The final part of your portfolio will be the web research section. And so we're going to want you to show how you research information for 3 different programs. Note they don't have to be all, a Java one, a C Sharp, and a C++ one. Just any 3 programs. And what I want you to do is show the documentation and then show the code that you use to write to use that documentation, and then explain a little bit about what the problem was and how you used that research to find it. Now, it's quite possible you didn't preserve every single search you ever did. Just do another search and find the current version of the documentation you had used and use that. And again, you lose points here primarily by not explaining clearly what was going on. So that's the portfolio. The next section is the debugging quiz. So we're going to set up a time. It'll probably be in that last week, just before this portfolio is due. I'll probably use that Friday so that you can go take the debugging quiz and then let me know. Take that debugging quiz and turn in your portfolio at the same time. If you have any dates in that last week that you can't do, please send me an email so that I can figure out those dates. And then what we'll do is your debugging quiz will be 2 hours and 15 minutes long. You'll have all that time to work on 3 programs. I'm going to give you 3 broken pieces of code: a C++ program at the 1275 level, a C Sharp program at the 1280 level, and a Java program at the 2235 level. You may only get the for example, the CPP files, and you may have to take those files and turn them into a project, or I may give you an already built project in Visual Studio, and you can just use that. But in that time, you're going to have to put together a project, put those files in it, and get the program to run. And so it's just like other debugging quizzes you've taken. Basically, you get all the points if you fix all the compiler errors, the code runs, there's no runtime errors, it doesn't crash, and basically it functions the way the code is expected to function. I'm not looking for you to make it the best program in the world. I'm just looking to you to get it to function as it was clearly intended to function. So you shouldn't have to do super extensive things. Just get the code to work. And the spec is the same for all 3 programs. Basically, if it doesn't quite work properly, then you're going to get a 3. If it crashes when you run, you're going to get a 2. And if it doesn't compile at all, then you'll get a 1 for that. And that concludes the review of the spec. And just as a summary, basically, you're going to provide 3 things: a USB with all your programs and a folder for the capstone, your portfolio with an explanation of each one of those topics we described, and then you're going to take a debugging quiz. Thank you very much.